All right, let's talk more about slope. We'll do problem 3 from the textbook. At what values of x does the graph of f have a horizontal tangent line? The horizontal tangent line, oh, that's just going to be right here when x is equal to 1. Right here when x is equal to 3. And here when x is equal to 4. Those are all the places that have a horizontal tangent line when the derivative equals 0. Letter B says, what values of x is f the biggest or the smallest? Well, it's biggest over here when x is equal to 4. And it's smallest over here when x is equal to 3. That's not a coincidence. Later on, we'll talk about how to find the maxima and minima. And most of the time, it'll be when the derivative equals 0, when the slope is flat, when the tangent line is horizontal. Now, C is going to be more difficult. Sketch the graph of the slope of the line tangent. Sketch the graph of f prime. This is going to be hard. This is what we did at the end of our last video. We're going to have to graph a bunch of points, make a table. All right. So at different x's, what is our derivative? We already know some of them, but let's have space for 0, 1, 2, 3. Maybe we'll do a 3.5 again. And then 4 and then 5, just like the last example from the last video. Well, we already know the slope is 0 at 1, 3, and 4. We already found that. All right. And then just like before, well, what's the slope right here? The slope looks like it's 1, right? We extend this line and look at rise over run. Go up 1, right 1. The slope looks like 1. At 2, very similarly, right? This is what our tangent line looks like. What is the slope of that? It looks like it's -1. 3.5, that's a little harder. Pretty darn steep. It's a little hard. Let's say that this point over here is like 3, -2. So it's kind of like we're going, you know, kind of like we're going up 4 and right 1. Kind of like this. Let's say the slope is about 4. And lastly, at 5, again, it looks like that slope's that same -1, right? Because we're going down 1, right 1, roughly. We're just making approximations here. And now we have to graph this. All right, so let's just kind of copy this out a little bit. Five, 4, 3, 2, 1. Oh, we are going to have to go a little bigger, though. We did have a pretty big slope. All right, and let's plot these points. Again, the red graph is f of x, and the blue graph will be the slope of the red graph, f prime of x. So, when x is 0, our slope is 1. When x is 1, our slope is 0. And then we just keep copying the values from the table. When x is 3.5, our slope was 4. When x was 4, our slope was 0 again. And at 5 is back to -1. And just like before, look at this whole region. This whole region has basically the same slope. The slope is basically 1 for this whole area. Constant slope almost. And then it jumps down. Very quickly it changes. And then it's -1 for a really long time. All this region. And then again, it very quickly changes and gets very steep for a while. And it gets back to 0. And then it stays at -1 for a while. Again, all this region, the slope is kind of very close to -1. This is what its derivative looks like, and this is how you do it. So it's pretty difficult. I'd say this is one of the more difficult aspects, but very useful for you to understand the relationship between a function and its slope. The blue graph will tell you the slope of the red graph at any point, which is kind of cool and very powerful. Let's do the same kind of thing. I wish we stayed with the same colors. The functions were red, and the derivatives have been blue. For this whole section, I'm just going to recolor. All right. So the idea here is to look at the slope of the red functions. So what's going on with the slope of this red function here? Well, the slope is always 1, right? This has the same slope. The steepness is always the same. And it's just 1. And then the steepness really changes to -1. We go downhill, but it's all -1. And then we immediately bounce back to +1. So the slope should be +1 and then change to -1 and then change back to +1, but it should be the same on each of those pieces. Which one's that going to be? That's C. Slope, blue represents the slope of the red. Notice that blue is staying at +1. The function value of blue is staying at +1. The output is staying at +1. And then the output jumps to -1. And then the output jumps back to +1, and it's constant on each of those pieces. What's happening with this next one? Well, hold on. I don't like how I copied this. It's a parabola. The slope is pretty steep and positive. And then, oh, here's a really good thing to look for too. At 1.5, at an input of 1.5, the slope should be 0. Which one of these has a value of 0 at 1.5? Right here, slope is 0. Slope is 0. Blue is slope. So here's where the function value is 0. Ah. That's a really good thing to look for. So this is going to be A. And you could do a similar logic with the first one that we didn't do. Notice at these 2 points, there is no slope, because the slope from the left is +1, the slope from the right is -1. No slope at those points is why we have open circles here. All right. And then again, another way of looking at this guy over here, big positive slope, small positive slope, small negative slope, big negative slope. Bigger positive value, smaller positive value, smaller negative value, and then more extreme negative value, like so. All right. And of course, that means this is probably B. But let's make sure. The slope starts off very close to 0. Right? The slope here is very close to 0. Notice the function value here is very close to 0. The slope is steepest in the middle. Notice the function value is biggest in the middle. And then the slope gets close to 0 again. The function value gets really close to 0 again. The slope of the red is the function value of the blue. That's a relationship with f and its derivative, f prime. Derivative is slope. All right. Hopefully this helps. These are tricky stuff, kind of makes your mind go all into tangles. But the more you practice it, the better you'll get. And you can ask me questions as well. Best of luck, and October says, oh, that's Theodore. He's there, by the way. That little lump in the blanket. He loves his, well, he loves my blanket, okay? And then, yeah, bye-bye.